Students, in this problem, they're giving us empirical formulas along with a molar mass, but they're not giving us the molecular formulas for each of these compounds. So what we need to do in each case is add up the number of atoms of each type that are found in the empirical formulas to get an empirical formula mass, and then we take the molar mass divided by the empirical formula mass, and we should get a whole number. That whole number you would use to multiply the subscripts within the empirical formula and end up with the molecular formula. Let's tackle part A. Empirical formula is SNH, and within that there's one atom of sulfur, and if you look up the atomic weight of sulfur, it's 32.1. There's one atom of nitrogen, whose atomic weight is 14, and one atom of hydrogen, whose atomic weight is 1. That gives us 47.1 grams per mole. That is not the molar mass, that's the mass of the empirical formula. So we call that the empirical formula mass. To figure out how to get the molecular formula from the molar mass, take the molar mass and divide it by the empirical formula mass. So in the case of SNH, they provided a molar mass of 188.35. That's right up here in the problem. And we found an empirical formula mass of 47.1. When you divide those out, you get a whole number. Well, you get it on your calculator, you'll get like 3.99999. So something wickedly close to a whole number. Just call it 4. So that means that the empirical formula to molar mass ratio is a 1:4 ratio, which means in the actual molecule that contains S, N, and H in a 1:1:1 ratio, there are actually 4 times as many atoms as are listed in the empirical formula. So take the subscripts within the empirical formula and multiply them by this whole number ratio that we came up with. That whole number 4, we multiplied the subscripts of in the empirical formula to arrive at the molecular formula. Let's continue on to the next one, and I think you'll get the hang of this. Our second one, so this is part B, they give us an empirical formula of NPCl2. So I would go about doing my bookkeeping, where I'm looking up atomic weights on the periodic table. There's one atom of nitrogen, one atom of phosphorus, and 2 atoms of chlorine. And I round to the 10th place because you don't need to go any further than that. When you add all those up, you get 115.1 for the empirical formula mass. Not necessarily the molar mass. Sometimes empirical formula mass will match the molar mass, but not always. That would only be the case if the empirical formula and the molecular formula for a compound are identical, but that would be a coincidence. We'll take the molar mass divided by the empirical formula mass. And in this problem, in part B, they gave us, up at the top, 347.64 as the molar mass. And we had just determined the empirical formula mass to be 115.1. When you divide those out, you should get a number that's really, really, really close to a whole number. And in this case, it was 3. So that means you take the subscripts within the empirical formula. So an implied 1 for N, an implied 1 for phosphorus, and a 2 for chlorine, and triple them, because your whole number ratio of molar mass to empirical formula mass is 3. So that gives us N3P3Cl6. That's your molecular formula. Part C, they give us CO, C4, O4. And if we look up on the periodic table and do some bookkeeping, there's one atom of cobalt whose atomic weight is 58.9. There are 4 atoms of carbon, each of which have an atomic weight of 12, so that adds up to 48. And if you add everything together, you get 170.9 grams per mole. That's, once again, the empirical formula mass, not necessarily the molar mass. And then if we divide molar mass by empirical formula mass, you should get a whole number. They provided a molar mass of 341.94, and the empirical formula mass that we found was 170.9. That works out to be almost 2 right on the nose. So that means your whole number multiplier for all of the subscripts within the empirical formula, so you got a 1 for cobalt, a 4 for carbon, and a 4 for oxygen. Double all of those, and you'll end up with the molecular formula of the compound. So 2 cobalts, 8 carbons, and 8 oxygens. That's your molecular formula for part C. Moving on to D, they give us just SN for the empirical formula, so I'd go about doing the bookkeeping here. It is good to follow a procedure once you've got it. I recognize you might be able to do this one in your head, and that's fine too. You're welcome to do that. So this adds up to 46.1 grams per mole. That's the empirical formula mass. And if we take molar mass divided by empirical formula mass, we should get a whole number ratio. The molar mass they gave us up above was 184.32. And the empirical formula was 46.1. On your calculator, if you type that out, you'll get a whole number ratio that's really, really, really close to 4. So that means take the implied subscripts in the empirical formula and quadruple them to arrive at the molecular formula. So, oops, it's S. S4, N4.